All right, geometry. Last video here for lesson 10.5. So let's go to this next problem here. It says, what is the value of x? So we're going to talk about how to find parts of segment lengths in circles. So this is actually two chords here. So chord BD, chord AC intersecting. We need to find x. So we're going to talk about some use of similarity here. So way back to topic 7. So I'm going to draw two segments. I'm going to draw BC and I'm going to draw AD. Right? So you can see I just created two triangles, right? I'm going to prove that these two triangles are similar to each other, right? Using angle-angle similarity. All right, and again, we're going to use our inscribed angle talk. So if I take a look here, right? So if I look at angle A and angle B, these two angles both intercept. If you trace angle A out to C and D, if you trace angle B out to C and D, they both intercept arc CD. So angle A is going to be congruent to angle B because they are inscribed angles that both intercept arc CD. Okay? We'll do the same thing with angles C and D. So C is here, it intercepts arc AB. Angle D is here, it intercepts arc AB. So angle C and angle D are congruent. Again, by the same reason, right? They're inscribed angles that both intercept arc AB. I could have also used the vertical angle pair here at point E, but I'm not going to because I only need two angles. And now I know that these two triangles are similar. So triangle A, we'll go AED, is similar, that's like the little tilde, is similar to BEC, triangle BEC. And again, that's by angle similarity. So now one of the things to remember about sides of your similar triangles is that they're proportional. So we're going to use the 4 side lengths that we have 3 of the numbers in x, all right? So I'm going to use AE from the first triangle, and that's going to correspond to BE of the second triangle. And that's going to equal ED from the first triangle, and that corresponds with EC from the second triangle. And again, that's because corresponding sides of similar triangles are proportional. And now if I substitute what I see in the picture, so AE is 6, BE is 4, that equals ED is x, and EC is 5, and I'm going to cross multiply. So 4 times x equals 6 times 5, divide both sides by 4, and we get an x value of 7.5, and that's the value of x. Okay? And now, if we take a look here, right, this relationship, these proportional sides, when you cross multiply, create two cross products, right? This right here. So this was 4 times x equals 6 times 5. It was these two segments, 4 and x, and then these two segments here in green, the 6 and 5. And that's exactly the theorem you're going to see on the next slide. All right, so we have two theorems here. So the first one, right? Well, actually, this is one theorem with two. There's actually 3 cases, right? So now, the product of the lengths of two segments from the point of the circle is constant along any line through the point and the circle. So that's a lot of hubbub. I don't even know. Again, I'll put a question mark there, right? This first case is called the 2 chords case, right? So this is the 2 chords case. So in the 2 chords case, you simply multiply the 2 pieces of the chord. So A times B and then C times D. And that's it. So that's your 2 chords case. Okay? In case 2, this is your 2 secants case. Right? So 2 secants. Now for 2 secants, you have to kind of remember this one very specifically, right? So notice that the first part is n plus m. So that's the entire length of the secant, n plus m, times n, which is the outer part. So right, it's called the, I always do, it's the whole secant times the outer part, Same thing over here. Q plus P is the entire secant times Q, the outer part. So it's the entire thing times the outer part equals the entire thing times the outer part. You got to try to remember that for secants. Okay, and then last but not least is your sorry, I didn't mean to do that. Is your secant and tangent case, right? So if you look at this picture, the third case, you have a secant, the YZ, and a tangent that is labeled as X, right? So for a secant tangent case, notice that you square the tangent. So this is a tangent, X squared, and then for the secant, again, it's the same thing. You add, they do Z plus Y, so I'll stay consistent with them. You add the two parts, so Z plus Y. That's the first part, and then you multiply by the outside part, right? So this is the secant tangent case. Okay, and for this one here, just to show you, I'm not going to go to Savas. So the tangent is 6, so 6 squared is 36. The secant here, this whole thing is 9. So if we did 9 times 4, that's also 36, and they're equal, right? So there you go. All right, so let's do one example involving this problem, or one of these cases here. Again, you're going to have to prove some of these on your homework, so make sure you have this idea of similarity involved, right? Inscribed angles, creating triangles, all that fun stuff. Okay, so this is the last example here. It says, archaeologists found parts of the circular wall that surrounds an ancient city. They measure the distances shown. The 272-meter segment lies on a line through the center of the circular wall. What was the diameter of the circular wall? So again, they just give you a piece of this, right? So this is the wall. If I continue that circle, right? This is the circle they're talking about. Let's say the center, well, this 272 lies on a line that goes through the center of the wall. So that if we extend this, right, that means it goes to the center. And this is our problem. We need to find what is the diameter of the wall. We need to find this length x all the way across. Well, this is our two secants case, right? Both of these segments go into the circle, intercept the circle 2 points here and here, here and here. So this is your two secants case. So remember, for two secants, you have to do the entire secant segment times its outer part. So this entire secant segment would be x plus 272. X plus 272. So we're going to take x plus 272 and multiply it by its outer part. And the outer part is 272. And that should equal, I'll change it to blue, this entire outer piece, which would be 310 plus 805. So 310 plus 805 is 1115. So 1115 times the outer part of 310 equals 1115 times 310. Okay, so when I distribute this 272 over here, I get 272x plus a big old number, 73984, and that equals another big old number, 345650. I'm going to subtract 73,984 from both sides to get 272x equals, and when you subtract that, you get 271,666. Uh-oh. And then we divide by 272. And you get an x value rounded of 998.77. Rounded to one decimal, I'll call that 998.8, and that would be meters. And that's how long the diameter of this circular wall would have been. All right, perfect. So good luck applying these rules to your problems and solving some questions in your practice assignment.